Assalamualaikum and salam sejahtera everyone. Welcome to another session of business statistics. In this session, we will be focusing on chapter 8, interval estimation. So interval estimation is the use of simple data to calculate an interval of possible values of an unknown population parameter. So interval estimation is in contrast to point estimate, a concept that we discussed or learned in chapter 2 and chapter 3 in business statistics, where for a point estimation, we are focusing on a single number or a single information, while in an interval estimation, we will try to determine two possible points where we believe that the actual value of the population is located. I repeat, in interval estimate, we will try to determine 2 points. Instead of 1 point, we will try to determine 2 points in which we believe that the actual value of a population is located. So here we have a question. Question 6a. The snowfalls in inches during the month of January in a particular geographic region is normally distributed with a population standard deviation of 15. In the last 20 years, the sample average of snowfall is computed as 110.80. So there are 3 important information that we obtain for question 6a. First is the population standard deviation, that is 15. Second, the sample size, that is 20 years. Third, the sample average of snowfall, which is 110.80. So this is the formula that we use to determine the interval estimate. In this formula, there are 2 important components. First component belongs to the point estimate, and it is denoted with the symbol X bar. So in this case, based on the question that we have, this X bar represents the sample mean. Our sample mean will become our point estimate. So that is the reason why at the first component, in the first component of our interval estimate, we use the symbol X bar. Another important component, the second component in our interval estimate formula, is the margin of error. The margin of error. And in the margin of error, we have 2 subcomponents. We have 2 subcomponents. The first subcomponent is the z value based on a specific significance level that is divided by 2. I repeat, the first subcomponent or the first component in the margin of error is the z value based on a specific significance level that is divided by 2. So the reason why this significance level is divided by 2 is because in the interval estimate, we have 2 critical values. We have 2 critical values, one to the right, the other one to the left. And we also refer these critical values as tails, left tail and right tail. Another component in our margin of error is the standard error. Just as I mentioned in our previous session, when we try to determine the normal distribution based on a sample, then the standard deviation has to be divided by square root of the sample size in order to obtain the standard deviation for that particular normal distribution based on a sampling method. So the second component in our margin of error is the standard error or standard deviation based on this sample of 20 years of data. So this is the population standard deviation. We divide it by square root of the sample size, denoted by the symbol n, lowercase n. So the first question that we have in question 6a is construct a 90% confidence interval of the average snowfall in this region. So construct a 90% confidence interval of the average snowfall in this particular region. So since we don't know the actual value of the population due to certain constraint, we may not be able to obtain the actual value of the population. So that is the purpose of sampling. The sampling will help us to understand the behavior or the information that we try to retrieve from a population. But even though we have collected the information based on our sample, but the information that we obtain from the sample doesn't necessarily means equal or 100% exactly the same as the actual information that we wanted to obtain from the population. So interval estimate will help us to estimate, to figure out, to determine 2 points in which we believe that the actual value of the population is located. So in an interval estimate, we will produce 2 points in which we believe that the actual value of the population is situated. So back to question 6a. 1. Construct a 90% confidence interval of the average snowfall in this region. So we use the same formula. So the first component based on the equation refers to the point estimate. In this situation, our point estimate is the sample mean. Sample mean is equal to 110.80 plus minus. The reason why we have these two operations in the equation is because we will produce, as I mentioned before this, we will produce 2 points. So that is the reason we have 2 operations, mathematical operation in the formula. And then we have the z value. And this z value is determined based on a particular significance level that is divided by 2. So in order to determine the significance level, all that we have to do is to subtract the confidence interval by 1. In other words, 1 minus confidence interval is equal to significance level. Since our confidence interval in this question equal to 90% or 0.9, thus our significance level is equal to 1 minus 0.90. So the significance level is equal to 10% divided by 2. Remember, the reason why we divide it by 2 is because we have 2 critical values in the interval estimate. One to the left, another one to the right. So this confidence interval, we can simply say that this confidence interval shows the percentage, the chance of obtaining correct estimation, or the chance or percentage or probability of obtaining precise information, while the significance level, since significance level is equal to 1 minus confidence interval, we can simply say that the significance level shows percentage or chance for us to make a mistake in estimating the interval estimate. And the second component in the margin of error, as I mentioned before, this is the standard error. So standard error is the product of division between population standard deviation 15 with square root sample size, in this case 20 years. So in order to determine the z value, we have to refer to a table known as t-distribution table. So this table shows us the z value based on certain significance level and by referring to a particular degrees of freedom. So if we move back or go back into the question, we can tell that our significance level is equal to 10% divided by 2. So we refer back to this particular T table. So this is our significance level, 10%. And if we divide it by 2, we have 5%. 5% on the left, 5% on the right of the critical values. So we will be focusing on this exact column. Another important information that we need to have in order to determine the z value apart from the significance level is the degrees of freedom. So the degrees of freedom based on the question, in order to determine the degrees of freedom, we have to identify whether we have the information about population standard deviation or sample standard deviation. We have to know whether we have the population or we only have this sample.